Hello, my name is Rebecca Wheatley. I'm technically actually 35 seconds early. Slash. I do that. I will wait and let a few more people trickle out on lunch. I hope you had a lovely lunch, whether it was boxed or otherwise. I should be able to do this presentation in the full 50 minutes that we have here for the session, but I would likely talk too quickly and too early, and then hopefully you will ask me questions, because fundamentally this journey has many different pieces, and I try to focus in on the physical component of it since we're here at Data Center World. But if it is not the part that is most interesting to you, I would love to have your questions. So there will be time for Q&A at the end. I believe we are now officially getting started. And so, hello, I am Rebecca Wheatley. I'm a structure engineer at GEICO. GEICO is the third largest auto insurer here in the United States. And I have worked in semiconductor systems and previously at cloud service providers before coming into this enterprise space. And I did it because I wanted to drive this journey here at GEICO. So it has been a real honor, and it is a real honor to work for a company whose mission is really to help people every day. We don't sell anyone's information, we just try to keep you in your homes, in your cars, doing the right thing. In this day and age, that's a nice thing to be able to say. So this session is all about our journey for on-prem infrastructure and data center. In order to take you through that journey, I have to go back in time about 11 years to when GEICO made the decision to go all in and evacuate those data centers. So I'll take you through the journey, how we got here, and how we decided to come back. The cheeky thing to say would be in the next 15 minutes, I could save you 15% or more on your car insurance or on data center infrastructure. I hope you'll find in our numbers, we're saving a lot more than 15% for these cases. And I hope you'll see this isn't easy. And nobody's journey is easy when you're looking at changing massive aspects of your infrastructure. So whether you're going to the cloud, whether you're coming from the cloud, there's a set of pitfalls that are very typical. I'll try and talk about the ones we hit. I'm sure there are others that others have hit. And so we'll try and do that correctly. So we were founded in 1936. No, I do not have any data center systems from 1936 that are still in my data center. My data center ages from the 90s, not the 36. But we are, number 3 auto insurer in the US. We have about 30,000 associates. We're distributed all over the US, including Hawaii. That's the best office, obviously, for everyone involved. We have 24/7, 365 service model. That means from an infrastructure perspective, we have to support all 400 physical sites that we have at all times. We also sell a variety of other products. We are in property and life insurance and many others, motorcycle. So insurance is our business. It is absolutely everything that we try to do in a 24/7 methodology. So I will start, like I said, to understand the cloud journey we've been on, I have to go back to 2013. In 2013, GEICO operated 100% on-premises, like most enterprises at the time. This was an interesting model. So we have 2 primary owned and operated data centers. We had 3 co-location facilities that were sort of our transport hubs. And then from the acquisition, we had yet another carrier-neutral facility that we were using. That footprint was the backbone of the 400 physical sites that were all of our field offices. We were on mesh stripping, we had lab systems, we had separate SAN. That was not what our UCS Blade servers were. We were a very traditional enterprise house running very proprietary, very managed systems. We even, like many enterprises, chose to lease aspects of our systems. And we did that for financial reasons, that we wanted to be able to do sort of service operations and management in consistent fashion versus the CapEx ups and downs that often happen when you're doing infrastructure just about the cycles that you actually develop and have amortization of. that led to delayed infrastructure repairs, that led to delayed infrastructure actual refurbishment, and that meant that we were seeing less reliability than we wanted to see in our on-prem data centers. We were seeing more latency, and we fundamentally believed that going to the cloud was going to unlock our developers to do more, better, faster, and stronger. So under that premise, with all of the courage and conviction that a CIO can have, we decided we were going all in on the cloud. And we partnered with a very good cloud provider at very early in their journey for supporting infrastructure. And that meant that we got to see all the days of early cloud development, particularly for traditional enterprise type workloads. So we, for those who are not in the software space, do have a lot of Linux stacks, right? Your traditional Linux stacks. We also have a lot of Windows servers. We have a lot of what I mentioned before, CS Blade servers. We have a lot of transactional databases, large transactional databases from all the vendors you would assume, Oracle, etc. With that footprint, going to the cloud is incredibly expensive. I have transactional databases that will time out without 1.5 milliseconds of latency between transactions. Even if you're in the same region in the cloud, they will only guarantee you 2 milliseconds. It's nearly impossible to guarantee those kinds of functions will happen accurately in a cloud footprint. And we didn't have one of those. We had 678. So the migration to the cloud, fast forward 11 years later, our bills were 3x the cost. We still hadn't evacuated our data center because certain mission critical applications could not migrate to the cloud with the cloud architecture. We had gone from 99.9% availability down to below 90s. How is that possible? Well, it turns out if you go not to one cloud, but 8 different clouds, yes, friends, 8 clouds, and you don't actually evacuate your data center, if you haven't actually looked at your network topology and how you're going to handle identity and access management, you will create a massive surface area problem. So it's actually just that I am the cumulative uptime of all of my different vendors. And when I add that many more, I create that many more scenarios for an outage. And so that wonderful experience of 3x the cost, losing 2 nines with availability, and not actually seeing any mean time to deployment increase. Then we decided to reverse our decision. Now, I want to be really clear that clickbait aside, saying we're returning from the public cloud sounds so great. We're still very avid users of the public cloud. We will continue to be avid users of the public cloud. It's about using the cloud where the cloud is best for ephemeral compute, for experimentation, for things that are not yet fully established workloads. But when your core business that you are running all the time needs to log things for 7 years for clients in this country, or needs to do standard billing and assessments and back end that are based on typical models or actuarial tables, which are not done with actuarial tables these days, but it's a lot of ML that has to be processed on a huge amount of data. That work is very consistent. And those of us who work on-prem know if you have a consistent workload where you can plan for it, where you can optimize around it, where you can increase your utilization of your assets underneath, that is where you can really optimize on-prem versus in the public cloud. Even if you do reserved instances, even if you do any kind of buffering for reserved instances, if you go over, you get penalized significantly. If you go under, you get paid for it whether you use it or not. And so a lot of the aspects of sort of cloud economics that make sense for working out of your garage and spinning something up as a small provider don't make a lot of sense for large-scale enterprises with predictable workloads. Again, fantastic for experimentation, fantastic for doing non-prod, trying something new, but once it's become an established workload for your company, you can usually run it at much better economics on-prem. And I promise I'll walk you through that. So, 8 clouds I talked about, that's including IaaS, PaaS, and SaaS. I talked a lot about the size. In our largest cloud provider, we had over 200,000 cores. A core is not a core. Those cores went back 10 years in terms of age because, like many enterprises, once you move to an instance type, upgrading to the new instance type requires redeployment, requires tuning and optimization, which a lot of people don't even do. It's running well enough. And so that thought process of I'll get more efficiencies going to the cloud, again, if you don't have a constant redeployment mentality or philosophy, you're unlikely to get that out of the cloud. Certainly not going to get it when everything's running on VMs and nobody ever wants to let it go down. Okay. I mentioned we got to 80%. I'm looking at my notes to try to capture it all on me. Yeah, and 3 exo builds. So fast forward to 2023, and this is when we decided to revise our decision of all in. And like I said, that doesn't mean we're leaving the cloud entirely. What that means is that we really wanted to address the rise in cloud costs. We really needed to address our reliability challenges by decreasing that footprint. And we really needed to control our rate of innovation. So like many enterprises in 2023, we looked at AI and where we wanted to expand our spend for AI. And you need to find that efficiency somewhere. Your CapEx budget did not triple just because you want to do something interesting for your associates' productivity. You need to find the right opportunities for optimization. And in many places, that's your core infrastructure. That's that dependable workload that runs the back end of your billing system or the back end of, that's where you want to make sure you're doing it much more efficiently so that you can free up the dollars to go invest in the AI space. And if you haven't done that, your CFO is going to be calling you soon because there's no other way to fund it, right? That is the only opportunity we have as businesses to be more efficient in cost to serve, to support the way the businesses want to grow with AI-assisted customer, voice interactive services, et cetera, et cetera. So that really was the kind of combination of solutions that made us say, okay, it's time to look at this. We can do this better. We know we can. We're going to take this effort on. And modernization is always an effort. And I do call this modernization, right? Whether you're coming to the public cloud, whether you're going from the public cloud, you are looking at how you modernize your workloads and your applications, you modernize your infrastructure, you modernize your path to that infrastructure and your network. You have to address all of those components to be able to truly transform the experience for your business. And I'm talking too fast. I do it all the time. Okay, so where do we start, right? Where do you start when you're looking at this? For us, looking at our public cloud footprint, we really wanted to understand our workload profiles, both what we had today and what we were moving towards. So for us, that was really the backdrop that ensured we wanted to look at and what things we would look at for repatriation. I'll talk about that more in a second. So first, key decisions that we looked at. We had all of our own managed, operated, and owned data centers. They were 60 miles apart on the same carrier with the same power delivery mechanism. No, that is not a good way to run your data center. So one of the big decisions that we made was to move to a colo model, a distributed, geo-distributed co-location model. I know you're shocked that you would want to get out of these older data centers. Part of this was looking at the remediation timelines for our own operated data centers would be 2+ years and many millions of dollars. Not the right choice for us, especially at the time. Versus a colo model where as you fill, you pay as you fill that rate. So you make a commitment up front, but you don't have to pay it until you're actually filling according to that data center. So that was one critical decision for us. And I think, again, a very good decision for most enterprises looking at our modernization. It's just, again, you can run the economics. It all depends on your utilization. It all depends on getting it right. But assuming you get it right and you size it correctly, if you understand the load, it's a much better economic model than doing remediation on these older sites. Also, you may find the older sites are co-located with humans. And what's good for the humans is not necessarily good for the machines, both from a security perspective when you're a highly regulated industry, and as you think through the spaces, locations, where I have good cheap power, where I have good connectivity, not necessarily where everyone wants to live. So decoupling those two really does enable you to do much better things for the business. Next one, from OEM to ODM. Now, this is just a business model, right? OEMs and ODMs is just a business model. And there's good things about OEMs and there's good things about OEMs. So what I really mean here is going to that design manufacturing approach. So buy what you need. What we have been doing with leases, with proprietary operating systems, with proprietary software management services, whether that's VMware, whether that's an SEC kind of solution, is incredibly expensive. Again, I'll show you the numbers in a little bit. It's incredibly expensive. This is why the cloud looks so good to so many of us who were operating on-prem before the 2010s. There's a lot better ways of doing it. And you can do that whether you use an OEM or an ODM. Using an OEM and an ODM methodology is another option in between. So I'm not recommending one versus the other, so there's trade-offs in both. But leveraging standards such that you can use multiple vendors, buying just the hardware you need, not buying all the proprietary stuff on top, and leveraging OpenBMC, leveraging open firmware stack. These are methodologies that allow you, even if you buy it through a different vendor with support, that allow you to upgrade your place, to retrofit your systems, to upgrade the amount of memory that's on there. Things that you can't do in the OEM systems without a huge amount of incurred cost. So you end up not being able to operate it for as long. You end up having all sorts of reliability challenges because each managed system has a different management stack, has a different control plane, has a different methodology for handling thermal events. And so you can't operate your data center in an efficient fashion unless you buy everything from one. And then you're locked there, just like you were locked before. So we really wanted to take that approach with open standards and build on top. And again, whether you use that ODM style with an OEM or from an ODM directly, there's pros and cons, and it depends on your team more than anything else. Back to the open strategy, right? With open hardware designs, we also paired that with open software. So you may have heard that VMware was acquired by this company called Broadcom, and they really crazily changed the cost structures of how we use vSphere and other management solutions. Like many other enterprises, we did not want to pay 14x for what we've been paying in the past. And those were the kinds of quotes we were getting. So we made the decision to move to OpenStack. OpenStack has been a fleet management tool for going on 15 years, I believe. It's had a lot of evolution. It's helped a lot of people get really excited about it in the last 2 years since this acquisition. There's a lot of co-travelers in the enterprise space that are using OpenStack to try and do fleet management and solutioning. So that was a big part of this transition for us and a major aspect of our cost savings in driving our on-prem fleet management costs down. And I say OpenStack, which is inclusive of Ceph, but I feel Ceph should be called out separately because Ceph is its own SDS solution. It is a big deal to offer your own managed solutions coming from a SAN. So definitely was part and parcel of the transformation. The last area that we really had to think about as we looked through this journey and design was our coverage. How many people still use a VPN in their environment? Yeah, I would expect a lot of your hands are up. The way that legacy networks were designed was we all came into the office, but this thing called COVID happened in 2020, right? That was what happened. Yes, that for us at GEICO was transformative. That was the first time our associates started working remotely. They weren't able to work remotely before they always came to the office. And that created a huge amount of latency for our associates. Because of how we have designed our network topology, we're backhauling every bit of traffic to HQ, to our data centers, and then taking it out through our CNS, and then going to our public cloud providers through a private network interconnect, or even worse, through a separate sort of access management control layer from a protocol perspective to the internet. So we had 3 hops of latency for every packet that was going between an associate and the internet or development. It's a great way to pay top dollar for your cloud and have a miserable development experience. So we really had to work on our network. So those were the 4 key areas that we had to look at. So I mentioned, the fun that was our network. This is what I inherited coming in, and I think what many enterprise networks look like. So MPLS was a great protocol, a very excellent protocol if you were doing low jitter communication for a call center, right? MPLS makes perfect sense at the time. What was the average traffic type that we were serving to our associates? My friends, they were on WebEx, or they were on Zoom, or they were doing team meetings. They were all on video. I was starved for bandwidth. Could not get more than 200 associates on call together. Turns out there was not a single business team that didn't have an all-hands meeting once a week that needed way more than 200 associates. Remember, we have 30,000 associates. So, massive bandwidth challenges, massive latency challenges, could not serve our business needs. Because we were on MPLS, that also meant we were on UVN. Well, didn't necessarily mean we had to be on UVN measuring. We chose to be on UVN measuring because boy, were we going to make sure it was rock solid from a reliability perspective. That put us on a single vendor, single point of failure, single vendor. You know how many outages I had on average? Over 190 across my fleet on average a year. Constantly challenged. Huge problem. So the experience was expensive. It was high latency, and it was not serving me. So, friends, this was our first effort, and it was an ongoing effort. It was the longest effort. You're dealing with 400 physical sites, and you're trying to break a UVN mesh. You have to change the router at every single site. You have to change the connectivity at every single site. You have to order new circuits. Everything's got to change, right? So this is by far and away the longest lead time of our associate experience transformation and the most critical, I would argue. So what do? We're doing this in a 3-stage, and we're in phase 1, to be clear, which is an estimated overlay. All that allows you to do is effectively extend the VPN gateway out without the backhaul bandwidth issues. That means that from a remote office, they get a direct line to the internet instead of having to go back into our primary data centers from a backhaul perspective. So we changed the latency. It also allows us to go to direct internet access from MPLS because of the router we chose and the circuits we chose. So that allowed us, from a cost perspective, to increase our bandwidth by 10x, which is more than we currently need, but gosh, it's always surprising because the average time at which we make bandwidth changes within a network tends to be 10 years. Right? We'll make a compute upgrade maybe every 2 to 3 years, but we'll only change your bandwidth on your network every 10, sometimes 15 years depending on your business. So better to future-proof up to the next level of what you need than to, go a little too cheap on this one. That was certainly the decision that we decided to make. So this is the first phase of the SD-WAN. It's the physical layer that allows us to extend the privacy and controls out to that edge to remove the backhaul. And again, with DIA, it allows us to increase the bandwidth at actually a significant cost savings, even doubling our circuits. So we have redundant and distinct upstream providers from each of those sites. So this is a massive part. Obviously, the next phase is SASE. For those who are not familiar with the SASE protocol approach, this is really breaking the VPN and going to an overlay with a cloud-based protocol overlay. So it's the same security policies for isolation, but you do it at an internet service provider layer or at a CSP layer to be able to inspect the traffic and policy before you send it across. This will allow us to be that much more efficient from a backhaul perspective for our associates. So it's one hop out. It doesn't have any separate tunneling challenges that SD-WAN is the physical tunnel, and we're already using an overlay for an external tunnel to the internet. So unifying those whole things largely decreased, I won't say nothing because it takes a lot of time to get it right, but largely allow us to have much more consistent policy enforcement for in and out versus having 2 different methodologies by which we do that, which can lead to reliability challenges. So it's one phase of a 3-phase effort to hit all 400 sites. That full timeline is just shy of 3 years. So for those who are looking at this, you're starting your network, it's going to be your long pole, no doubt. I mean, even just ordering circuits can be a 90-day timeline at every single site. So really it is the long sleeve type of lumbar belt. You know, the one thing I would definitely say is even when you think you're getting diverse circuits, and those who are in the colo business probably know this better than most others, but for enterprises, one of the key lessons learned is ask for your KNCs. Trust but verify. That is a common theme that I will talk about in this session. Trust your vendors. Most vendors are great, but verify. They may not realize upstream one box, they're going through the same conduit. Like, if you don't look at their design files, you won't know. And particularly for your data centers, making sure you have real diversity is critical. The most you're going to see most of your outages happen in the last mile, right? So just having a colo with two different entry points on either side of the building, so they're on two different sides, two different streets, will help a lot. But if you don't have that, if it's coming in on a common location, at least try and make sure upstream you're giving yourself diversity in terms of the business. And again, that's because we had so many challenges with network uptime. The other area I would say here for SD-WAN in particular, but even for new routers, even anything in this equipment domain, the importance of an RFP and RFI, the importance of a full-scale POC to test out your system. It's just a wireless router. What could go wrong? No. Don't trust the data sheet. Do your research and your homework. Always make sure that you test it out and validate it. And the good news about it is that it is just a wireless router. So you hadn't tested in production. It's not the end of the world. Could be the legacy switch still working and actually carry that traffic. So, trust and verify. So yes, now at least we're at the place where we have not got significant bandwidth challenges or overlay challenges in terms of backhaul. So this was and is the fourth thing I mentioned, but the first one I wanted to dive into because it is one of the most significant for user experience. By the way, I'm talking about the edge network. I didn't even really talk about the network topology within the data center. I'll talk about that as we kind of delve into some of the hardware aspects. So 400 physical sites around the edge, all of them going DIA, 10x the bandwidth, moving to an SDA overlay, and then moving eventually toward a SASE model. For the core data center, this is where we had 2 primary owned and operated, 4 colos around it, 3 phase phone transit, 1 essentially an acquisition that needed to be immersed into the world of new and also data centers. So in this space, there's a couple of key domains we really tried to look at. When making a server selection, this is my heart and soul. Like, I love servers, so probably betraying my bias here. The first and most important thing is really looking at the workloads. So again, with this distributed footprint of 8 different clouds, you can't solve every problem. And infrastructure and building your own infrastructure is not good if you go deeply heterogeneous, right? You want to be homogeneous. You want to move towards a more cloud-native footprint. You want containerization. VMs are fine. That's also a denser workload model. But you need a methodology to do better bin packing. Otherwise, you don't get efficiencies out of it. So if you're buying 20 SKUs, you're probably doing it, right? It's not, economically, it's not going to work out well for you. That's not the right choice. So we really looked at what we had. We had servers that were 8 years old, 10 years old, had been on lease models, leased back. So the opportunity for high performance improvements was like night and day. A lot of our servers had 12 cores, 14 cores. We had a few that had 24 cores. What's available on the market today is up to 128 cores. There's even vendors out there that are selling 256 cores. Unclear to me many workloads that will scale well to 256 threads. So, not necessarily the right choice for us to go that far, but a lot of efficiency in that market has been delivered in the last 10 years. Simplifying and streamline management. So we decided to go with a common motherboard. Sometimes it's a good choice, sometimes it's a bad choice. I like a common motherboard because if you're doing any of your own development in terms of your fleet management controls, your firmware, if you have a common motherboard, your validation efforts are easier, your effort for building out that firmware stack and ensuring that it's set correctly from a topology point of view is a lot easier. So that's why we decided to go in that direction. And then we decided to make some choices that would enable us to be future-proofed, right? PCI Gen 5 at the time was new-ish. I won't say new, but new-ish. Not all the boards had it. Lots of them still have PCI Gen 4. I didn't have a use case for Gen 4. I decided to enable for Gen 5. There's some additional cost on the board, but it was de minimis to be able to support additional components that would get more efficient over time. And the same was true actually looking at some of our different specs that were available at the time. So we tried to take advantage of, for example, OCP NIC form factors that we got out. Again, that even though we were buying 25 gig NICs, 400 gig NICs at the time, they will enable us to go further and faster if we need to scale up for AI use cases over time as we see UVC getting broader adoption and not necessarily in an isolated cluster for that. So reduce, reuse, recycle. The more that you build out modularity in your systems, the more you use standards in your systems, the more you can upgrade and retrofit over time to meet the needs of the business. Because right now we still are very diverse, and as we go more cloud native, more containerized within our fleet, we will be able to leverage more of the homogeneous use cases. But we still needed to support some of the large transactional databases that time out 1.5 seconds. So you can't go too far too fast. Another part that we really, I already mentioned, we went with OCP Unix, we went with, I talked about NHS from a modular compute system and framework. We also decided to go with DCSCM. That was for security and control. There's a lot of interesting innovation that's happening with side coprocessors, for lack of a better term, in that space to be able to do secure boot methodologies, to be able to do deeper encryption. And so right now, I don't see a use case from an HSM point of view, for example, where we can use a PKI service that's in the cloud to ensure that we have enough secret management to meet our regulatory needs. But that is an incredibly expensive service. And so looking at something like a DCSCM, where you could insert or generate high activity keys for your own key service, is one of those spaces where, if you want to go through FIPS compliance or you use a card that does FIPS compliance already, you could take on that use case and further optimize your cloud spend. So when you're looking at that cloud spend, there's sort of the first tranche of low-hanging fruit, which is the fungible compute. But then there's the really expensive services that you pay top dollar for, that may be good ones to look at. And they're often around security, they're often around AI. Those are, if you be predictable about them, which keys certainly we're very predictable about, have an opportunity for a better cost savings. So that was really to kind of future-proof some of our options within the CICM space. And then the other thing we decided to go with is because we were building out greenfield. I don't know if we would have made this decision, and in other jobs I've chosen not to make this decision because we were dealing with much more of a brownfield build. But we decided to go with ORV3. And ORV3 for us was actually both a power density choice, it was a cost saving. And again, it's fine because we have the space we were building out so we can get the racks that fit our location. So, do I see one? Here we are. So that meant with a modular box, we could hit 5 different primary use cases for a call center with one primary validation effort. So that allowed us to shrink down our validation times from 9-ish months to closer to 3-ish months per system, because you're just validating the differences in the board, right? The timing on an alternate methodology for your memory within your BMC or other factors like that. Your thermal design. Boy, was that different. Because if you have the same motherboard and you have all your SSDs on one side, you're seeing very different airflow than you don't have all of your SSDs for your standard compute labs. So really testing your thermal design with this is a major learning. Not learning. It was known, but gosh, definitely check it. If you don't check your fan table, it's going to be really, really different in terms of airflow when your full rack is actually, populated versus lots of air. Okay, so ORV3 was the right decision from a cost and a power density point of view. It was not an easy decision when it came to certain components. One of them being our network here. So if you're not familiar with ORV3, it's a DC power. It allows you to do very fast DC power, and that was very easy for our servers, right? That made us much more efficient overall for our server design. But most standard network gear is 19-inch and it's 80. So you gotta figure out how to make that work in this rack. So that was a key learning. It was not ideal. We ended up working with a contract manufacturer who was fantastic to basically do a PowerShell 7 connector. And that allowed us to do a splitter and do a C13 off of that. Not an ideal situation. Now I can tell you that at least Dell has ORV3 networking gear that is available. More and more vendors are coming online with DC-based networking gear, but that was not available when we were purchasing our first round. And that was a fun hiccup in this journey. The other thing to kind of think through when you're doing a migration like this, we're bringing up 2 new data centers, but we're still operating the older 2 data centers. And as you're testing, particularly for workload migration, you need a common fleet. So you need to stitch the old data center, which in our case had a separate L2 and L3 network, across to the new data center, which had flat L3 topology. That was also fun. The methodology for doing that for us was actually to build out greenfield in our older data center and have common pooling across to stitch the L2, L3 via OpenStack in one physical location, and then to do the migrations across OpenStack between the new site and the old site. So kind of a 2-phase migration approach. In order to do that, we definitely found that ORV3 enabled us to change aspects of our legacy data center power potentially. So all of our older operated data centers were on UPSs. We could have looked at PDUs, we could have saved money on that. We talked to our insurer, they said, no, not your choice. So even though you can save money and do some interesting things with ORV3s, I would not necessarily recommend the BBU approach from a buyer point of view. It's definitely riskier, but it is quite cost effective. We definitely have enjoyed innovating, I think, in some interesting ways with our PowerShells. And I think that is what's coolest about the ORV3 rack. So we're continuing to iterate on our density, and it enables us to use these common racks from a distribution perspective, all the way through to potentially GPU designs as we go to higher and higher power and consistency for our data centers. So it was a great way to future-proof, very much appreciated it, very much would have loved to have networking here in the market that would be capable. So in terms of the cost of this, right, numbers talk. So what we found, and again, this is our use case for an OEM, this is where we were historically. So I'm just going to keep those. Okay. So in terms of cost effectiveness, this is showing you what the cost of compute in the cloud on a 5-year average was for us for 1,000 cores. I'm normalizing on cores, even though these cores were Haswell cores, Broadwell cores, X-Lake cores, all sorts of cores, right? So on average, obviously that's part of my soul dies when I say such a thing, but that is what I'm normalizing on for the sake of convenience, because many of these workloads were running again. And so they weren't necessarily taking advantage of anything in that core, other than the average rate at which it's blocked. So we're normalizing on cores, we're normalizing on memory, we're normalizing on petabyte of flash storage, which, because we have large transactional databases, that was the predominant methodology that was being used. There was not a lot of pool storage that was being leveraged, which is an optimization opportunity, whether you go to the cloud or not. This was our general energy savings, our general cost efficiency, and our general consolidated management option. So it takes into account the weighted cost of the OEM with our licensing fees, the weighted cost of our cloud with our licensing fees, and the weighted cost of the ODM-based systems without license fees because they're running open source. So I'm not lying in the numbers, but the numbers are not just hardware, because we couldn't run in the cloud without all the licensing fees. We did not run our legacy OEM systems without all the licensing fees. But a lot of the savings you see, not just from the hardware, you see from moving to open source simultaneously. So I want to just be 100% transparent about it. This was our numbers for compute. It was 50% storage, a first 50% savings per every one of those unit cost elements. If you go look at storage, that is where there's 60% savings, and that's just flash. Like, that's without doing any kind of storage tiering for logs and legacy environments that you need to retain for a long period of time that don't get touched very often. So huge opportunity once we get it on-prem to do further optimizations in the storage space. Okay, so I mentioned the network transformation to get to all of our sites is just shy of a 3-year journey. Again, full transparency, but this is not an overnight thing. Nobody should take on a journey like this without having a commitment to it for a 2-year life cycle. It can be at least 18 months to 24 months, depending on what your number of data centers is, your number of users, your number of workloads, your number of clouds, etc. So we started this journey, made the decision in May of 2023. In June of 2023 is when we got our first samples on systems to start testing, and in October of 2023 was when we really started to engage in an RFP process for our servers, our development, design, our racks, everything we were looking at for data center co-location spaces, etc., etc. The next year is when we really started to get into our testing of the servers at our owned and operated data center sites, when we started to actually do our co-location selection. We made those decisions towards the middle of last year, and then we started to build out of that. You'll see the big red July 2024 timeline. This is when we had to go through a significant number of BOM revisions due to thermal and power challenges, some of the AC-DC converter, inverter options that we had to go through to make our racks work with our network gear that we had collected, etc., etc. This was a major part of delay, about 2 quarters from what we had hoped to achieve, which was just doing business in the world of physics, right? But again, full disclosure, those were massive challenges that required rework of servers, there's all sorts of fun things to make sure that everything was working in the right way. Linked flapping, we had all sorts of interesting opportunities for improvement, as we always do when we're actually dealing with hardware. So that meant that in the beginning of this year was when we were really at full data center readiness for our first site, which was the best moment. I mean, I have 2 little boys, I love my boys like none other, but this data center was probably the next closest joy of my life in having it come up. Cannot express to you the joy that was happening. And then the next one, when I got a blinking cursor going across L2, L3 network and actually stitching the thing together, was fourth, but again, very high on the list, moments of joy. And we're not even close to done, right? We're in the middle of building out our second colo-based data center. That will come up within the next 2 quarters. We have an exit that we did in January. We have another exit that's happening in 2 months from one of the other co-location facilities that was our legacy environment. And we will be going out through 2027 for all of the network design and development and state. So this is not, it's not an overnight thing. It takes real time and effort. But once you've selected your servers, once you've actually got rack design and topology working, once you've actually got your pod configuration out, once you've done the design for the network topology, then it's like Legos, right? You just gotta keep following the instructions. Go to the next one, go to the next one, go to the next one. And each and every one we get better, faster, stronger as a team in moving this data center and remediating so many challenges that were in our legacy footprints and really helping associates. And I think it is that experience, going out and working at a call center and working with a call center agent and hearing from them how much better that they were literally using 2 different laptops at one point to try and do a call so they wouldn't lose connectivity. This one went down, and use the other one and back up. I mean, the experiences they were having because we had not remediated the network in so long was unbelievable. And yet our associates would make it happen because we care about our customers. But it is unacceptable in the infrastructure space to be giving them that service. Absolutely. So it's real joy to see every single time we do an office and their entire experience is transformed 300 times better. They're all getting on their Zoom calls. I'm like, yay, it's so great. It made me happy. So challenges and lessons learned. There's nothing, you can't talk about these kinds of remediation journeys without focusing on some of the challenges and hiccups. I try to do it along the way. But one is when you're buying OEMs, hardware and software does not come together. That's a major. But it can also leave bugs. So you really do have to do all of your verification and validation. Lead times. Nobody in this room is at all surprised to hear that lead times can be surprising and not at all what you thought they would be. So market volatility and lead times, you know, it's great to have a location where you can inventory where you need to. If you inventory too much, now you're sitting on too much. So definitely, we saw massive fluctuations in different domains. You probably saw on one of my slides. GPU availability was such that, like, I might have grandkids before the GPUs show up, which is a fascinating and interesting opportunity in this market for alternate vendors, and that's exactly where we chose to go, which is, I hope, will lead to some of our primary vendors making different considerations in terms of how they supply and allocation. In terms of requirements, you know, again, when you're working with an OEM, there are so many parameters on the board that can be set. If you do not, if you give a list of 21 requirements, guess what, friends? You just let a bunch of them float. That's not going to work well. So be detailed. Make sure you are asking for what you need. Trust but verify. Get the logs. Ask for the logs up front. If they say they did 8 hours of burn-in tests, they should have logs for that. You should be able to see. You should know what the pan settings are, A to B and C. Like, these are not rocket science, but if you don't check, they may not have realized that the ideal level 9.4 for NIC is 42 degrees and you're operating, or they're running the fan assuming it's going to be at 65. You're going to have overheating issues. Like, these are, again, not rocket science. It's just checking the data and making sure that you have set the requirements where you need for the devices that you have, because they may not have, right? So detailed requirements is huge. Staffing is real. So the people who know how to build data centers and operate infrastructure are the same people, whether they work at a CSP, whether they work at a systems company like an ODM, whether they work at, you know, an enterprise. And you have to compete for that talent. And that is true. It doesn't take a huge number of people, but they need the right skills. And so you need to assemble the right team. That is critical. If you've been operating the same infrastructure on a leaseback model with an OEM only, it's a different team who knows how to operate OEM systems and colos. And you can upskill and you can partner together, but you need to see your team with the right skill set to be successful in that journey. It's going to be a minimum of 24 months. Like I said, our network is going to be closer to 3 years. Our data center transformation will be closer to 24 months. It could have been 18, but it was going to be 24, and I'm going to deal with that. And start small. Use a small use case, right? Use your non-prod workloads. Make sure you evaluate your infrastructure first, your network bandwidth and telemetry aspect. Start small, test, do things in phased controls before you go to the next one, before you go to the next one. Sounds silly, but the scientific method is there for a reason. It's all business and robot things. So if you're thinking, if you're on this journey, if you're another enterprise out there, I don't know if any of you are, I'm happy to talk about it. It's awesomely fun to get to play in both the world of the cloud and look at those economics and look at what we're doing there and optimize there, because I have a cloud team too. Today we've been talking about the physical side of this, but a lot of the physical side cost structure analysis was paid for by optimizing our cloud bill, right? All the storage, flash only things from the cloud that were costing us a lot of money, all those places where we went ephemeral and we could have done reserve and had a better sort of cost structure, we were able to really optimize our cloud bill, which helped clear up capital to actually do what needed to be remediated on site to improve the overall experience. So think about that. Don't ignore your cloud bill just because you're focused on the other. It will inevitably hit you if you do. So I would really advise start from your network. Really think about the path your associates, your employees have to your network, through your network, to the cloud, to the internet, whatever they're doing every day. Do you have enough bandwidth? Have you made protocol choices that are interesting? Do you have reliability challenges? Like nothing affects your associates more than their network experience. Number two, figure out your annual workloads and services. What's not changing for the next 5 years? What is a predictable load? How can you improve those to be able to deliver and anchor your business case? There's a massive change to go from an OpEx cloud model, even if you're spending 3 times more, than to go to a CapEx model where you have to do capital outlay on the front end. You need a really good financial partner and team. I'm very blessed in one. And you need to be able to show that value over time. So it really is anchoring on key workloads that are going to be core to the business, that are predictable and understandable to justify your first build costs. And make sure you have, I mentioned my financial team, ensure you have strategic alignment. You cannot do this, it affects everyone. I am moving every single packet our company and distributes, which affects our customers, it affects our business, it affects everything. I like to be a duck on the pond where nobody has to know how hard I'm going. You cannot do that here doing physical site access and operations. You will have disruptive incidents. We actually not that in 2 shutdowns had any disruptive incident to the business associated with the migration, but that's because we've done a huge amount of testing for BCDR before we even touch a migration site. They have to be aligned. And I said it, trust but verify. It's absolutely critical that you hold your vendors accountable. They're wonderful people. They're not sociopaths. They want to do the right thing for you. But if you don't ask them, they won't do it. They're in business too, or they don't want to spend extra money doing things that you haven't asked them to do. Make sure you're doing controlled migrations. I talked about this a lot. You're doing good disaster recovery testing on any of your sites. That is your red teaming for aspect of migrations. Like, leverage those processes. Make sure you've done your data backup, recovery, and control. Make sure you have your assets secured in the right fashion so that you can do the right testing to be able to actually spawn your migration. And don't pretend it's going to be 18 months. Well, just know it's going to be 2024, it's not going to be here. It does not spin up or down like a cloud. We actually have to build things in the real world, not take more time than you think. So adjust your expectations wisely. If you are at all interested in our journey, this is obviously a link to our opportunities that are open here at GEICO, but we also are involved in all of these open source communities, KVM, OpenStack, OpenBMC, ZEP, you name your favorite flavor. Of course, you can always get it low. Okay, any questions for me? Yes, I love questions. Oh, hello. I have my. Yeah. Oh, well, you know, I had that too. I'm used to being around servers with big fans.
I don't know if that's working. So Steve Caroselli, I'm the CEO of a physical security company.
Yeah.
One of your earlier slides mentioned about $300 million a year in spend. I'm assuming from your passion and your talk, you've already identified the other things, better associate experience, lower downtime, et cetera. What are you seeing on the savings with the transition?
Yeah, so interestingly, I think we're about 10% of the savings in, because again, you have to look at it, you do the capital outlay to build out the new systems, And then you also are starting to bring down your cloud bill. But you have to do the capital outlay first before you actually bring the cloud workload back. So that's why I have a small team that is absolutely 100% focused on cloud optimization of bills. And there's always opportunities. And I have a separate team that's working on the network edge transformation from the core. And a lot of our savings is in that network edge transformation, coming off of MPLS, even though we're increasing the bandwidth, allows us to return a lot of capital back to the company. So we definitely spend a lot of time looking at the numbers. I never want to be in a situation where I'm above what my CFO or CEO would expect. But it means you are constantly looking at the net present value of what you're building against what you're operating and trying to manage that and overages. So we're constantly looking at our cloud bills.
Thank you. So we could see 16 or 17% savings in the future
so
on our auto.
The overall, we'll end up at a 15 to 50% savings depending on the unit cost of the core storage. So we already see that where we're running for those specific workloads. When you amortize the full cost and the way that CapEx is spiked on the front end, it looks like 10% rounded to that over a 2-year timeline. Yeah. Anyway, come grab a mic. I won't hear you, by the way. I'll try.
Awesome presentation.
Thank you.
It's clear you've done a lot of research and there's a lot of things you're holding back from even bringing up. Thank you again for all of that. I'm disappointed there's not more people here. It shows that there's a lot of motivation and momentum around staying in the cloud, which I find a little unfortunate. You mentioned, and correct me if I'm wrong, that AI adoption was one of your motivators for going back on-prem. Can you talk more about that?
Yeah, absolutely. So when 2023, obviously everyone got really excited about generative AI. As an insurer, we do a ton of machine learning. It is a data business. It is a rate to risk model. The core business is how well you rate the risk an individual is coming quickly. So we're constantly crunching data to build profiles of risk for any bin, for any entity business that we're in. So when I look at our business model versus other infrastructure I've run in parts of my life, we are way over on storage as an insurer versus, say, as a CSP where it's heavily compute-based. We have a ton of storage. Again, we store all that data, we store all the logs, associated information, and we are fully regulated. So at any time, an auditor might ask us, why did you choose this read for this person at this time? So every single one of our models has to be time-based, and be able to be indexed for different rates based on different states. Some states want 7 years, some want 5. So our retention rates are different by state and different by use case. So with all that said, we are always and always have been very storage and ML heavy. But when you start looking at generative AI, it's a different cost structure. Now, I don't see the core business as where we want generative AI. Who wants somebody to hallucinate someone's rate? Like, friends, not my part of the business, but I
Goes down.
pretty sure beyond who is our chief data officer would not be excited about that idea. So we really try and focus those use cases on internal. So a lot of the transformative uses for AI are actually in customer service, in agent experience, in ways in which we can make it easier for data discovery for our end users. So it's not how we expose, again, the rate to risk modeling, which is very locked loaded and very volatile, but it is how we transform the experience for users. And that really, when we first started the Nexus, there was over 400 different use cases that have been brought to the front. And, back of the envelope math, which infrastructure people do all the time, because otherwise we never, you got to know your financial background. When we looked at costing out what that might be in the cloud versus on-prem, even if we could get the actual instances, we were looking at another $100 million of usage in our cloud. And again, but we're not going to do that unless we find 100 million stateful routes, right? So that was the opposite. We have gone through 400 different use cases, right? We're down to what we think are most effective. We're running the right experiments to do the right things to get the ones that are actually going to have value to the company. But certainly that's the major hypothesis for why we looked at this and why we are involved. Also, the other thing to think about in your AI strategy is where's the data? So if your data is distributed across 8 different clouds, you're going to spend egress costs to move it to wherever you've got those GPUs in those reserved instances, like you have the wait 9 going forward. That is a huge amount of cost to just move your data around. Versus if you know this is data you're going to operate against and you have to keep it for compliance reasons on-prem, you put GPUs there, don't move the data. So again, the lead times on GPUs, not ideal. 9 months is shorter than 52 weeks. So it depends on the GPU, it depends on the
microgrid.
But it's about
Okay, so we're doing a lot of work with power.
Thank you.
No problem.
That was good.
Any others? I know I'm probably at 10.
You bet.
Curious to know, like, for such a large, complex migration, what are some of the risks in execution that you guys have to deal with, and then some strategic thinking on like, how would you mitigate those risks? First question, and then would you go back and do anything differently after all this?
Mitigation of risk. I think, there's so many areas where sometimes there's great things about every company and things that are core to ethos. As an insurer, we are risk averse. And man, I have the best oversight and partnership with our physical security team. I have the best oversight and partnership with our compliance team, with our audit team. We have not first line risk, we have first, second, third, like many financial services providers. So in terms of risks, I had a very long list of risks and a lot of people doing due diligence on that. So I feel like risks need a really good upfront mindset for things I would do differently. Again, the ORB3 decision, I thought was the right decision. I think it is the right decision. The networking capabilities there and keeping that in sync, I wish I had kept in sync. I might have revisited the OEM purchase model from an OEM, especially now in the tariff market that we're kind of entering into. The differential in costs through the time were very significant. I have a strong suspicion in a new case in the future, and depending on where you are in your hiring journey, there's more opportunities from an OEM to subcontract specific functions and move forward. And now that we're seeing OEMs who are willing to engage on open designs with open source software and do that kind of variable model, it gives you an opportunity to kind of do more with less and choose what you're going to tackle. So it's a risk mitigation in a different fashion. So those are probably the two that I would look at again and say, over under where we were, I might be a different choice. Yeah, we'll talk more about it, but those are the two. Any others? Yeah.
I just want to make a comment really quick because I was at one of the cloud, even though I'm an on-prem guy, but I was at one of the cloud events back in November, and the content, Rebecca, that you just provided today, I hope everybody realizes this, is of that level. That's a 60,000 person event in Las Vegas. What you just provided today is of that quality. Everybody here is very lucky to hear from me today. Thank you.